Hey guys, let's discuss this problem. Uh, it's also a 1800 problem. As always, let's start with the example here. So in the example, first we are going to have four test cases. And for each test case, we are going to have a length, which is the length of the following array. And we are going to apply uh, some number of operations on this array. And the final goal is to find out with these two kinds of operations, can we change the array to a array only with zeros? So the first operation is to decrement by 1 k of the first elements of the array. So that means, let's say what we want to decrement by 1 for 2 of the first element. That means this array will become 0, 1, 1 because we deduct 1 from the first element and deduct 1 from the second element. That's the first operation. And the second operation is to deduct 1 for the last few elements. So for example, if we deduct from the last three elements, the resulting array is 1, 11, 9, 8, 5, 7, right? So we can apply any number of these two operations and in any order. The final goal is to uh, change the array into something like a 0, 0, 0, 0, right? If we can do that, we output yes. If we cannot do that, we output no. For example, the third case, no matter what we do, we cannot reduce it to array of zeros, right? Um, so how do we solve this problem? The solution of this problem is quite interesting. We're going to use differential array. So what is differential array? So differential array is an array deduced by the original array by store the difference between each pair of elements. For example, this array, we use the element minus the previous element and store the result in the differential array, right? So 2 minus 1 equals to 1. 1 minus 2 equals minus 1. And we have a imaginary 0 at the end for each array. So 0 minus 1 equals minus 1. So this is the differential array for this array. And another example, for this array, the first is 11. Because we have a imaginary item before the head of the array, right? And another imaginary 0 at the end. So the first is 11, the second is 4 minus 4, the third is 9 minus 7 equals 2, 6 minus 9 equals minus 3, 8 minus 6 equals 2, and 0 minus 8 equals minus 8. So why do we need the differential array here? So what we are going to find is a pattern here. So if we want to add 1 to first two elements, what happens? Actually, we are going to subtract 1 from the first two elements. What happened to the differential array then? So this item will become 10, right? And Let's change a color here. So we use red. This item becomes 10. And this item becomes 9 minus 6 equals to minus 3. Right? So as we can see, if we subtract 1 from the first two items, then this guy, the head of the array, will minus 1. And the end of our operation will plus 1, right? We can find the pattern here. So let's take another example. So forget about this one. So if we subtract 1 from the first 4 items, right? In that case, the first becomes 10, right? And the second still minus 4, because 8 minus 6 still equals to wait a second. So 7 minus 11 still is minus 4, right? And if we subtract 1, 6 minus 10 still equals to minus 4. And 8 minus 6 is still 2. And 5 minus 9 still minus 3. But here, 8 minus 5 equals to 3, right? So again, the head of the operation minus 1, right? 11 minus 10 equals to 1. And the tail of the operation plus 1, right? So that's the pattern here. If we use apply a operation from head to tail, then the head of the differentiator array will minus 1, and the end of the differential array will plus 1. So there is a similar pattern for the second operation, right? So for the head of the second operation will be subtracted by 1, and the end of the operation will be added by 1, right? So for example, if we want to subtract 1 for the last 3 elements, the last 3 elements becomes 8, 5, 7, and the differential will become minus 3. Actually, the differential will become minus 1. So become 1 because first is previously it is 2. So now it becomes 1. So it minus 1, right? And for the last differentiate, previously was minus 8. Now it becomes minus 7. So it's plus 1, right? So the problem is translated into we want to do some operations, and for each operation, the first operation is that we minus the first element by 1, and plus 1, add 1 into the last element of the operation. The second kind of operation is that we minus the head of the operation by 1, and the head can be some element in in the middle of the array, and the tail of the element, the tail of the operation will be added by 1, and it has to be the last element in the differentiate array, right? We have these two kind of operations, and after a certain number of operations, we want to make the differentiate array becomes 0, 0, 0, all zeros, right? So that is a much easier problem to solve, um, because for each operation, we only change 2 elements, right? So how can we know if we can change the differentiate array into zeros? So it's quite simple. Let's say we have differentiate negative differentiate in between of the array. For example, these two, right? And we have a positive first element, right? We just need to add them together and find out if the first element is still greater or equal than 0, because we are going to apply the first operation to the for the negative differentiate difference, right? Because the first operation will add a number to these elements and subtract a value from this element. So we need to make sure the number of operations can satisfy the array, right? That means we add this number to all these negative numbers, we can still get a non-negative number. For example, this one, we have 11 minus 4 minus 3. So we get 4 here is greater or equal than 0. So that means we can make all these negative numbers into 0. And of course, there there are still 4 numbers here, but we can easily subtract 4 from the first element, right? And for the positive um, elements in the middle of this array, we can do the similar, right? We just need to add them with the last element to make sure that in the end, the last element will be less or equal than 0, so that we can make sure we can change the positive elements in middle of the array into 0. And after that, we can easily change the last negative element into 0 by do the second operation, right? So I guess that's it. Let's look at the code here. Let's refresh this page. I should just submitted this. Oh, I haven't logged in yet. Sorry about that. So here we go. The internet is really slow right now. So here we go. So first we are going to read the number of test cases, then read the number of elements, and we read each element, and we calculate the differential array. And this is B is differential array, and A is original array, right? And this is the last element of the differential array. And we are going to add all the negative values in middle of the array into the first element of the differentiate array, and make sure it is still greater or equal than 0, right? And for the last element of the array, we add all the negative values in the middle of the array, right? And make sure the last element is still less or equal than 0. And if these two conditions satisfied, we output yes. Otherwise, we output no. So I guess that's it for today. Thank you for watching. See you next time.